Hello, my dear students. This is the second of the five video lectures on electrical circuit, and we are going to talk about resistors in parallel in this one. Last time, we saw the effect to the total current when resistors are present or connected in series, and we also figure out how to calculate the total resistance. If we will replace two resistors, let's say in a series, how with a single one, how large would be the resistance of that single resistor. In this one, we will practically do the same, but the configuration is different since our resistor is now parallel to each other. What now is the effect of that to the total current, as well as how do we now compute for the total resistance? Last time, we used the tollbooth analysis to figure out the effect of resistors when they are connected in series. So here we have two toll booths and they represent two resistors. The flow of the traffic, of course, is the current itself. So we said that if there are two toll booths like this, or even more, connected next to each other or placed next to each other, it would lead to slower traffic. But what would happen if we have resistors or toll booths that are placed parallel next to each other? Would it have the same effect? Would it lead to lesser current or slower flow of charges? Or would it be the opposite of that? Okay, so here we have a different scenario. This is actually how our toll booths are designed. So what happened is we have here three pathways for electrons or for the cars to pass by. And I can choose which toll booth I am going to pass through. So in other words, there are three multiple pathways for the cars to pass from this point to the other. So here are your resistors. The toll booths are parallel with each other. So when we place resistors, as it happens, when we place resistors in parallel, it has the surprising effect of actually increasing the amount of current that is able to flow through the circuit, because by then you have multiple pathways for the current to flow. So if we are going with the tollbooth analysis, you are not causing that much of a traffic, right? As compared with if you place these tollbooths, three tollbooths in series or next to each other, right? So if the tollbooth is 20 pesos, I can just pay the single 20 pesos on this tollbooth if I'm passing here, and at the same time, two more cars are able to do as well. In parallel connection, current is divided and flow through multiple paths. In series, you only have a single loop and a single pathway for the current to pass. So your charges will really have to pass through each resistors along the way. Arranging resistors in parallel leads to lower total resistance as compared if they are or if the resistors are arranged in series. So this is how your parallel circuit would look like. So let's say your current are passing through here, but when it reached this particular point, it have a choice, right? If it's going to pass through R1 or R number 2. At this point, the current passing through both resistors will join again, will converge again as one, and then you have your cycle, I guess. So just like what happened from the last video, what we want to find out is if we will replace these two resistors that are arranged in parallel with a single one, how much would be the resistor of that replacement? What would be the total resistance? So now what you are seeing here is your formula. for calculating the total resistance when your resistors are placed in parallel. Again, you are only going to use this equation when they are placed in parallel. Okay, so this might look a bit strange, but what you can see here is you have the reciprocal. The reciprocal of your total resistance is equal to the sum of the reciprocals of the individual resistances. So you have 1 over R1 plus 1 over R2 plus 1 over R3 and so on if you have more than 3 resistors. Okay, so let's solve a sample problem. You have 3 resistors. The values are 100 ohms, 200 ohms, and 300 ohms. And take note that they are connected in parallel, and we have to find out the total resistance. So we can use a step-by-step approach. So in the step-by-step approach, you first have to get the reciprocals of each resistance. That means how much is 1 over 100, how much is 1 over 200, and 1 over 300. After that, you have to add those reciprocals. And again, take the reciprocal of the reciprocal to find the total resistance. Let me show you. Okay, so this is for R1, 100 ohms. The reciprocal is 0.01. R2 reciprocal is 0.0005. R3 is this much, 0.003333. You have to add the reciprocals. That's 0.01833. And then you need to get the reciprocal of the sum of the reciprocals. So since this is, you just have to put it in the denominator here, 1 over that much, 1 over 0.01833. So that's equivalent to 54.55 ohms. So that's the step-by-step approach. This is very useful if your scientific calculator, I guess, cannot handle um, uh, a straightforward approach. But I wish you would use this one, the next approach, because I think it's a bit more simpler. Okay, so we put down our equation. So we only have 3 resistors, so we have R1, R2, and R3 here. And then we substitute the values. What we found out is, what I want you to do is to put down the fraction form of the answer. So the fraction form is 11 over 600. Remember that right here on the left, your quantity is 1 over R total. But what we want to find out is not the reciprocal, right? What we want to find out is the R total, not 1 over R total. So I guess we need to flip this over, right? So what we can get is the value for R total. Since you did that, on the left side of the equation, you also have to flip this. Instead of 11 over 600, 600 over 11. And you would get the same answer, 54.55 ohms. Okay, so that's how you would solve the total resistance if they are connected in parallel. I guess a bit more complicated than when you are solving for total resistance in series. Another very good observation that you should make is the total or the equivalent resistance of the circuit is less than the smallest resistor in the parallel network. Let's take a look at what we mean. Our total resistance is only 54, around 55 ohms. But what we have, our lowest resistor resistance is actually 100 ohms, right? So your total resistance would always be lower than the smallest resistor or resistance if you place your resistor in parallel connection. So it would actually give you lesser resistance. It would not add up just like in series connection.